Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help demonstrate how to check your Zoom 2 optical power meter for proper operation using a WaveSource single-mode light source. Patch cables in test equipment should always be checked prior to testing to ensure accurate and reliable test results. Usually a good time to do this is at the beginning of every testing day. Now in this procedure, we will be using the Zoom 2 optical power meter and the single mode port on the WaveSource optical source. You will see that we have 2 patch cables and 1 mating sleeve for this procedure. Okay, this reference cable is used to zero out the equipment and also to connect the WaveSource into the link under test. The second cable is used to plug the Zoom 2 into the link under test, and this mating sleeve is used to connect these 2 patch cables together to check them to make sure they're working properly together. Now one thing to make sure of when you are selecting reference cables is to make sure that the connector types are correct. In other words, you need to make sure one end of the patch cable is can connect into the port on the equipment, and the other end of the patch cable plugs into the link under test. Now these don't have to be the same thing. In fact, you could have LC in your patch panel and SC on your test equipment port, so you would need an SC to LC patch cable, or actually a pair of them actually. But in this case we're going to assume that the patch panels are SC, so we're using SC to SC test cables. Okay, the first step is to power on the testers. So we press the power button on both units. Okay, on the WaveSource, you'll notice that the multi-mode port is lit by default, so we need to switch over to the single mode port by pressing the port button. Okay, now turning our attention to the Zoom 2, we see that there's a reading of low on the screen. Okay, this is normal. What low means is that there's no amount of light coming into the photodetector. It's being blocked by this dust cap here. If we remove the dust cap, we'll notice that we get a reading on the screen. And what we're seeing is the amount of ambient room light entering the photodetector. Obviously there's no connector and no dust cap here, so the only light that's coming in is from the room. So just don't be alarmed, this is normal, and it's a normal power level as well. Okay, what we want to do now is to check this reference cable first. Okay, so we connect the reference cable into the single mode port on the WaveSource, and then the other end of the reference cable into the Zoom 2. Okay. All right, now notice that we're reading in dBm. Okay, this is what we want to do when we're checking our patch cables, read in dBm. Okay, but notice that we're set to 1310 properly here on the WaveSource, but not on the Zoom. So on the Zoom we need to press the wavelength button until we read 1310 nanometers. Okay, so now what we see is a reading of minus 10.54. Our target value is minus 10 dBm. That's where our single mode sources are calibrated at according to NIST. Now this is okay. The reading could be a little higher, a little lower, but it should be around minus 10. Okay, in this case it's a little lower, but it's still acceptable. If we're falling below minus 11 dBm, then there might be something further wrong with the cable and it should be replaced. Okay, so what we all want to do also now is to check both wavelengths if we're going to be testing both 1310 and 1550. So we simply press the wavelength button until we read 1550 on the Zoom, and then press the wavelength button on the WaveSource, so it switches to 1550. Okay, now we see a reading of minus 10.27. Okay, this is just also a little lower than minus 10, but it's still okay if it's not below minus 11. So both of these wavelengths are within their calibration level, and this patch cable is okay. But to check this cable, it's probably easier to check it if we temporarily zero out both of these wavelengths. So this is easily done by pressing and holding the 0 button for 1550. See, it says 0, and we switch to dB. Okay, but now we're reading 0.0 dB. That means we've zeroed out at this wavelength. But we also want to zero out at 1310, so we press the wavelength button on the WaveSource to switch to 1310, and then we press the wavelength button until we get to 1310 nanometers, and then we again press and hold the 0 button. All right, and we see 0 dB. Okay, so what we've done is we've zeroed out both wavelengths, and now we can check this second cable. So to do that, we have to disconnect the reference cable from the zoom detector port, and we'll see that we are reading ambient room light, temporarily while we're connecting in this second cable. So we put the mating sleeve on the end of the reference cable. We plug one end of this cable into the detector port, again reading low because there's no amount of light coming into the detector. And finally, connecting this second cable into the mating sleeve and completing the connection. So, as we see here at 1310, we're reading about minus 0.3 dB. Okay. What we want to do is we want to make sure we're not exceeding 0.5 dB of loss here. Reason being is that we are not zeroing out through this second cable, so we want to make sure that it is not introducing too much loss into our link. In this case, we know it's introducing less, about 0.3 dB, because at this point we're measuring the loss of the mating sleeve and the patch cable. So we know that this patch cable is okay to use. If we want to check at 1550, we simply, again, press the wavelength button on both units to switch to 1550, and we see we have a reading of around 0.3. Again, it's about the same as before. So we know that both of these patch cables are okay to use, and that the equipment is reading at its calibration levels, so we're ready to continue with our test. If the power level falls below the acceptable power level range, debris such as dust, dirt, or finger oil may have collected on the connector end face or in the equipment's optical ports. Thoroughly clean and inspect all connector end faces and equipment's optical ports according to industry standard cleaning procedures. Several cleaning cycles may be required. Keeping connectors and optical ports clean at all times helps to keep test equipment in good working order and proper calibration, ensuring accurate and reliable test results. When not in use, dust caps should be kept on fiber connectors and optical ports to keep debris from collecting on the surfaces of the connectors and ports. During testing, it is highly recommended to clean and inspect both connectors and optical ports every time a connection is made. Failure to properly maintain your test equipment could needlessly result in costly repairs. For example, over time, repeated connector insertions into a dirty optical port could grind the debris into the optics in an equipment port. This type of damage is permanent and cannot be repaired in the field. If the problem still exists after thorough cleaning and inspection, the patch cable may need to be replaced. Patch cables are typically rated for a few hundred connector insertions, but can prematurely wear out or become damaged if they are not properly handled and maintained. If the power level is still too low, even after patch cable replacement, contact OWL technical support for assistance. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.